Okay, now in the final installment of graphing absolute value equations, we have y equals the absolute value inside. We got x minus 3, then a plus 5 operation outside. So these make v's. So you go vertex start is always 0, 0. You want that there. Then the vertex finish, because we do have operations in here which shift the vertex. Now, you got to listen. Circle the inside of the absolute value itself. You don't know. Does that have something in there? It does. That has the opposite to the x, as you saw yesterday. So minus 3, I go plus 3. Okay. Now, does this stay at 0? No, because you have an outside operation. The outside does the same operation to the y. Okay. So you go to the y and do the same, plus 5. So it's 5. Now your vertex is out here, because x you got 0, 1, 2, 3, but you got to make 5 on your y, and you go to 3 and 5. Now you make your v. Just you keep doing that forever, but 7's good enough. Okay. Okay, example 2, y equals the absolute value. Inside we got x plus 4, then a minus 2. So you got vertex start, 0, 0, vertex finish. So inside, opposite, because there's something in there, you go down to your plus 4 is my laundry thing, and minus 4, opposite to the x inside, so it's negative 4. And then this outside operation does the same to your y, okay? So minus 2, you minus 2. Now let me explain why. Let's look up here. If I put a 3 in for x, what's 3 minus 3? It's 0. The absolute value is 0, 0, but we have a 5 added, so y would equal 5 if you put 3 in for x. Here, if you put negative 4 in for x, that's 0. So the absolute value is 0, but you're minusing 2, which takes you to a negative 2. So on x, negative 1, negative 2, negative 3, negative 4, and then negative 1, negative 2. So you go 4, 2. So forward 1, up 1, back 1, up 1. You just keep on going. And there you go. Okay, 2 more in this video. Y equals the absolute value of x plus 5, and then we have a plus 2 outside of the absolute value function. So vertex start, vertex finish. Okay, so inside the absolute value you have an operation. What does that do? It does the opposite operation to our x. So it's a plus 5, we need to minus 5. 0 minus 5 is negative 5. Now this outside does the same to our y. So it would be plus 2. Now let's make sure that makes sense. Negative 5 plus 5 is 0. Okay? The absolute value is 0, 0, but if you add 2 to 0, you're at 2. Okay? So if I do an input with negative 5 plus 5 is 0, absolute value is 0, but plus 2 is the output. Okay, so 0, negative 1, negative 2, negative 3, negative 4, negative 5, and then 1, 2. So 5, 2. Okay, example 4, y equals the absolute value of x minus 3, and then outside you have a minus 4. So you have vertex start, and then a vertex finish. Okay. Okay, inside the absolute value you have an operation. How does that affect the vertex? Well, the function, and not only the vertex, the entire function. -3, do the opposite to the x. So -3 plus 3. Now this outside operation does the same to our y. Okay? So I would -4. 0 minus 4 is -4. 3. And then -1, -2, -3, -4. So I go 3, -4. Okay, so there's your absolute value. Now again, let's make sure that makes sense. If I put 3 in, if I do an input of 3 for x, 3 minus 3 is 0. What's the absolute value of 0? 0. -4 is -4, so the output would be -4.